are you, everybody who is watching this video? My name is Olenjolaim TAYAI from the beautiful, fantastic, and wealth country, United Republic of Tanzania. And I would like to welcome you into our official YouTube channels, and also would like to welcome you onto this fantastic session. So I'm very happy to teach you today, and I'm very happy to have something to present before you and to share about the beauty of what am I going to teach you. So professionally or specifically, I'm a teacher of engineering mathematics and scientific mathematics. So I would like to welcome you. I would like just to share a few things to you before we go into the lecture, and which is lecture 3, or it is session 3. So I would like to welcome you into our YouTube channel that's called Online Undergraduate Polytechnic Institute of Tanzania in square bracket Olenjolaim. So remember that here we have this, the uniqueness. Okay, so this is the uniqueness, because you might find the content there online, but it's difficult to know that who made this content. So this is the unique identification. So this is abbreviations of the word undergraduate, and this here, it's a combination of the two words. Poly represent is abbreviations of polytechnic. Institute is just abbreviations of institution. So that's why we call it Online Undergraduate Polytechnic Institute of Tanzania, right? In square bracket Olenjolaim. So in this online undergraduate or polytechnic institute, we have many departments, but one of the departments is called engineering and scientific mathematics. One. So this is online undergraduate polytechnic institutions, not the physical one, right? And then the course that I'm going to teach you today is called Statistics for the Non-Majors, and you have studied in many institutions, colleges and universities in United Republic of Tanzania, in Africa, in America, in Europe, and even that in Asia and Australia. Students used to learn engineering, and scientific students used to learn statistics and probability in second semester or first semester of the second year. So the reference of Tanzania Commissions for Universities, mean TCU, because the focus of these modules is going to focus more on the universities and colleges under the TCU. This is abbreviation of Tanzania Commission for Universities. It means, for example, University of Dar es Salaam is under the TCU. University of Dodoma is under the TCU. So it means that University of Zanzibar under the TCU. So there are many universities under this TCU, but they have a likely curriculums in case of engineering and scientific mathematics. So I refer University of Dar es Salaam, this abbreviation of University of Dar es Salaam, as just like a reference in order to teach the contents, because you know the estimations that I'm teaching you by using the curriculums of University of Dar es Salaam is similar to the estimation that we learn in University of Egypt. They have just minor differences since. So I've been doing a lot of research concerning about these contents globally. It means worldwide, in different institutions. Higher institutions, it means that we call them best institutions, and even those which are moderate and even non-best institutions. So that's what the means of the reference. So today, the chapter that I'm going to teach you is chapter 6, according to the curriculums of University of Dar es Salaam, which is called estimation. In some of the institutions, for example, Dar es Salaam Institute of Technology, this chapter 6 is called the statistical estimation. So don't worry about the names, how it has been called. The issue is the contents. So make sure that you go through the contents. And if you remember, in my first lecture, I gave you the reference material that you need in order to learn statistics and probability. And when I gave you the reference contents, I told you that the first primary reference is what is course outline from your institutions that your teacher of mathematics will provide it for you. So again, I'll like just to share with you a couple of the things concerning about the program, and then just we'll go inside the session, so inside the lecture. I would like just to insist you to make sure that you subscribe onto this YouTube channel by using your valid email. That's number one. And secondly, I would like to ask you also to share these contents with your colleagues, with your friends, with your elder brothers, with your young brothers, and then share with anybody who can benefit from these contents. That's number two. Number three, also I would like just to insist you that to make sure you read the descriptions of this video so that you can get more information concerning about the contents that I've been teaching, but also concern about the other official YouTube channel. I have 6 official YouTube channels. This is one of them. So if you want to know about the other 5, make sure that you go to the descriptions below there and then read it carefully, take a note. And then the fourth thing which I wanted to share with you is in case my classes are incomplete, whether physical classes or these digital classes. They're incomplete if I don't give students a chance to ask questions. So I know that you'll be having many questions to ask your teacher, just like I'm teaching you in person. So I would like to insist you to use the digital facilities or digital platforms in order for you to ask your questions. Like myself, I'm recording the live class by using high definitions multimedia equipments in order to make sure that everything that you need to get or you have to get, you get it at the highest level, right? And even in high quality, highest level and quality. So again, I would like to insist to you that use the comment sections below the descriptions of the video. Use the comment section there to ask your questions, to answer questions that have been asked by the other students, and even also to have a group discussion at the students with other students in other institutions or other universities. And even myself, I will be visiting in the comment sections and see questions that have been asked by the students, and I'll try my level best to answer them. So remember that this program for the serious engineering and scientific students, you have to be serious even yourself. So when you be taking these lectures, you have to make sure that you are serious, you have all the facilities that are required for you to learn, and you have to concentrate on what you are giving because you are not wasting your time, right? So again, the last thing before we go inside the lecture, it is myself, well, God has given me a gift of teaching. I thank God for that and appreciate Him, and I give Him all the glory and all the praises because He deserves for everything that you are going to do, to see in this lecture and even in other lectures. I can say that I don't deserve any glory, any praise concerning about what I'm doing. Give all the praises and all the glory to the Almighty God, the God of Abraham, the God of Isaac, and the God of Israel. Means that the God of Jacob. Okay, so this is what I wanted just to make. Olenjolaim does not know everything concerning about the statistic, especially that this is higher, we call the higher statistic, because if you go for postgraduates, I told you that we will learn about advanced what is statistics. This is a higher level statistics. I don't know everything, but I just know the small portions of it, and I'm ready to share with anybody who need it. Okay, so let us go. So I believe that now you are in good position so you can go into the session. So I would like just to do the quick review of what we covered in lecture 2, that is still in the same YouTube channel. So you have to make sure that you go through the lecture 2 before we come into lecture 3. So in lecture 2, basically I began on teaching you about properties, right? Properties of properties of good estimator, right? Good estimator. So we say that the good estimator must be biased, the good estimator must be efficient, and the good estimator must be consistent, right? And then so I began to teach about what is consistent and what is efficient. And then next we went into types of types of estimation. What are the types of estimation? Because we say estimation is very important in statistics. What the importance of estimations, if you still remember? I told you that in doing research, or for example, that you want to determine a particular population parameter, such as mean, or such as standard deviation, so such as variance, right, of the particular population, of the huge population, for example, let's say 50 millions or 53 millions of Tanzanian, right? So, you know, if you say that you'll be dealing with the world populations, will be very expensive, time wastage, and even that the results might be incorrect results. So in order to avoid that, what we do as a statisticians, we used to take a sample, we draw a sample by using particular principles. So, and then we do the estimations of the population parameters by using the sample that we've drawn, and that's the meanings of estimation. So we draw the sample, and especially that in the topic called sampling theory, we teach you how we draw the sample, either from finite or infinite population, and hence we can determine the population parameters, and because the sample that will have the same properties, or we call it a good estimator, so you will find that the results we get from the samples will be equal to the results that we get if we could manage to do the research or the calculations or the computations when we've been dealing with the whole or the actual finite or infinite population. So types of estimation, we say we have two. So we say that the first one is what? Point estimation. This is the first. And the second one is called the interval estimation. So point estimations and interval estimation. Again, I taught you about what? I taught you about how we can deal with, we call it interval estimation or confidence interval estimate for what? For population mean. So I taught you about confidence interval, right? Confidence interval about what? About population mean, okay? Population mean of what? Of known variance, right? So of known variance, that's what we say, okay? Of known variance. So variance is known. And then we said, if you do remember that the estimate mean, say estimate mean, just I want to remind you this from the estimate mean, we say that this is given as mean, sample mean, then plus or minus, then you have what is standardized the value at half of the significance level, then you have what is standard deviations of what of sampling distributions of means, which this one is standard deviations of what is square root of 40 of sample size. So you remember this formula I told you, and then we did a problem or solve the question by using the z distribution. So again, I told you about another concept just to mention, confidence interval estimate for population mean when the variances are known, and we dealt with the large sample. We say that we have two types of the samples. So the first is so we have large sample, so a large sample. And then we say that the large sample, the condition to have a large sample, the sample size should be greater than or equal to 30. And then we have small sample that I will teach you in the next lecture, that will be lecture 4. Small sample, right? So the small sample, we say that the mean of the sample, the sample size should be less than 30. So I will teach you by using students' T distributions in the lecture 4. Stay tuned, you will enjoy the beauty of statistics. Okay, so that's the situation. So if that's the situation, against that, we dealt with that one, and the main focus in this case, we learned, I taught also about estimations of the difference between means when the population variances are what are known. So in today's lecture, okay, and then I left the homework, hopeful. Yeah, I left the homework, hopeful. And the homework was example, this was example 6.1, 6.4, okay. So it was example 2. And the question was saying that random variables x and y are normally distributed with standard deviations of 1.2 and standard deviations of 0.9. Random samples of observation. So I would like to do correction. So corrections for the homework. It was homework 1, right? Or just we call it, call it homework 2 because it is lecture 2. So we'll be calling the homeworks according to the lectures, right? And then we say that in random variables x and y are normally distributed with the standard deviation of that one. Means that this is sigma x is 1.2, and then standard deviations also for the second population, which is a standard deviation of y is 0.9. Random samples of observations on both variables, each of the size 32, provide the following informations. We have been given mean of x is 4.1 and the mean of 40, mean of y is 3.5. Estimate the difference between population means by means of 75% confidence interval. So that's what the question that we ended there, right? Okay, so let us do the correction for the problem that, or for the homework that I've left it for you. And let me read the question, then we go into this desired business. The question states that random variables x and y are normally distributed with standard deviations of 1.2 and 4, it means for population x, and then the standard deviation for population y is 0.9. Random samples of observations on both variables, each of the size 32, provide the following informations when the mean of x or population x is 4.1 and the mean for population y is 3.5. Estimate the difference between populations means by the means of 95% confidence interval. So let's say that correction, I believe, did you do the homework first? Corrections of homework 2, right? If I wrote homework 1, you can correct. So please, before just do correction, did you try to do that question? Let me know in the comment sections. The submission for the homework should be in the comment section. But because this is just the first homework, I will do the correction. So I believe that will be doing even many questions and even complex questions compared to this one. So how do you solve this problem? So the first step will be following steps. The first step, let us analyze the data given, right? Data given. So the data we've been given, we say that will be given the following data. The first one will be given standard deviation for x, population x, it's 1.2. And then we'll be given standard deviation for population y is 0.9, right? 0.9. And then we have mean, will be given mean for population x, this is equal to 4.1, right? And then we have mean for population y, this is equal to 3.5. Again, we'll be given each of the size, means that in the sample size for x in nx is 32, and the sample size for y, ny, this is equal also to 32, right? So the confidence interval, say confidence interval. So the confidence interval also that we have to estimate the interval estimation, this is 95%. So you know that we need to use it. So then that's all the information that you're being given in this problem. So that's the first step. We have analyzed the data that we've been given. The second step, we say that recall. Now the question also was asking determine the difference between the population mean. So difference between population mean, this difference between population mean, this is required. Okay, so recall the formula, because let me write properly for you in order to have a good arrangement of the notes. Okay, so the next data or the next thing, so the difference of means, because the question asks the difference of means, the difference between population mean. Difference between population mean is what required. Between population means, this is what required. So we require that one. So then what do you say? We go for the second step. The second step now, we have to recall the formula that I've told you. Recall the formula of what? Difference, of finding difference. Difference of what? Difference of means, right? Or difference between population means. Difference between population means. So that's what, so I told you that. The difference between, we find the difference between population mean, right? Population mean by using the two corresponding samples, by taking the mean of the sample drawn from population X minus mean of the sample drawn from population Y, right? And then plus or minus, then we have standardized the value at the half significance level, and then we multiply by what? By the standard deviation of sampling distributions of means, which this one also we call standard error. So also the standard error, the general formula for the standard error, whether it is for sum of the population means or for the difference of population mean. Remember that this one, so we say that here we have this one minus this guy. So you have to make correction. I think that in the previous lecture, I just said that here we have the standard error for the X populations. That is not true. So then we say that, but also from what? From the truth that the standard deviation, so are deviations of population X minus population Y, because you are finding the difference. Also, this one, I told you that is given as the square root of what? Variance of population X over sample size of population X plus what? Variance of what? Population Y over sample size of population Y. So that's why that we say the difference between population mean. So now the formula for difference between population mean, this will be given as what? The difference between the population means, right? And then say a plus or minus. Then I'll standardize the value at half significance level, and then say a square root of what? Variance of X, of population X over sample size population X, plus what? Variance of what? Population Y of what? Sample size of population Y. So that is. So if that's the case, we will be given this data, or this variable, we'll be given this variable, we'll be given this variable, we can find by using, because we'll be given the standard deviations of population X and population Y. So you can find this variable and this variable. We'll be given this, and sample size for population X, say the 2, sample size population Y is what? Is 32. So what are we lacking? The standardized value at confidence interval of 95%. So I told you that because we have different confidence intervals, can have 95 confidence interval, can have confidence interval of 99, can have confidence interval of 90, can have, so we have different values of confidence intervals, so should not cram. So I told you, but I would like also to repeat what I've told you, how you can determine the standardized value. So we say the second step now, we say that determine, or let us find what? The standardized value at dotting half of significance level. So how we can determine this one, which will be corresponding with a certain probability. So the first step, we told you that to find the significance level, we take 100%, which is total probability, and is equal to 1. We subtract it with the given confidence interval. So the given confidence interval for this case is 95. So then the response result is 5%. In decimal place is 0.05. Again, we want to find the half of the significance level. So how do we get? Take 5% divided by 2, and this will make 0.25. This will make 2.5%, and this is equal to 0.025. So then the first step will be using the standardizing Z distribution. That's the first step. So we say that is sketch the normal or Z distribution, normal distribution. That is Z what distribution, right? So to sketch the Z distribution, we say that this is the curve or the curve that we used to have. So this is symmetry, right? Where we say that probability is kind of 0. And hence, this is negative infinity, and this is positive infinity. So the total probability or the total area under the curve is what? 1, or total probability is 1, right? And hence, the probability from 0 to negative infinity is 0.5. The probability, we call it probability from 0 less than 30 be less than negative infinity, right? And then, so we say that is equal to what? So we say that less than 30, less than negative infinity, this is equal to what? 0.25. Similarly, these sections, these are half area under the curve, which is probability of 0 less than ZD less than positive infinity. Less than what? Positive infinity. So this one also is equal to 0.5. So when we say that, we are confident by 95% that the interval, the actual value, or the difference between means of the population lying between the particular interval. It means that where are we confident enough? So our confidence now, we believe that the response will be lying. So this is ZD alpha over 2, but negative, and also this is ZD alpha over 2, but positive. So it means that this is the significance level, half of the significance level. So this is total significance level if you take these sections plus this section. So what the total probability of this significance level? It is 0.25. And what the total probability here? It is 0.25. 0.25. So this is all about 95. So this is what we call 95%. From negative Z subscript of alpha over 2 to positive Z subscript of alpha over 2. So it's 95% or 0.95. That's the probability of the area under the curve. So then our interest, we want to know the value of Z at this particular point. So how do we know it? How can we find it? It means that we can find the probability from 0 to Z subscript of alpha over 2. Means that the probability, so we can find area under this curve. It means this, from here, we just go this way, this way, this way, this way, right? So how do? We know the total probability from 0 positive infinity is 0.5. And we know the probability from Z, subscript of alpha over 2 to infinity, to positive infinity, is what? 0.025. So how can we find this one? We take the total area, which is the total probability, we subtract the area shaded, which is just the significance level, half of the significance level. Then we get this probability. So after we get this probability, we have to use the Z distributions or the normal distributions, the normal Z distributions or the standardized distribution of Z to determine the corresponding value. It means to use the probability, we can use the probability to determine the value of 40 corresponding standardized value. Right? In case you have any question, don't hesitate yourself to ask in the comment section. Good. So, if that the case, then we say that fine. So then our probability, so we got that for the first system. So this the fifth system. I'm writing this system for you for future revisions in case you forgot the material. So you say that the fifth system, we say that if you want to find probability from 0 less than 30 and less than or equal to Z alpha over 2, then this will be equal to it. It's equal to the total probability of the area under the curve minus what? Probability of the shaded region, that is 0.025. So if we do that, means probability of Z less than or equal to Z less than or equal to Z subscript of alpha over 2, this will be 0.4750, right? 0.4750. So we found the probability at that particular point. So then we go for the sixth state, right? So we say that sixth state, we say use the probability, it means the probability 0 less than or equal to Z less than or equal to Z over alpha over 2, right? And what? And Z distribution or standardized distribution, right? Distribution, to find it, to find the corresponding value of what? Z of alpha over 2, right? Interesting. So I told you that when we're learning this course, you have to make sure that you have the tables, right? You have the tables so that it should be easier for you to do your computation effectively. So this is my table. So you should also have yours in hand, right? So this, they're given the probability that we know the probability, but we don't know the standardized value. Usually, we used to, in a given problem, you find that we can compute numerically what the value standardized value, and then so use the table to determine the probability. But today it's vice versa. So that's the beauty of mathematics. So I would like just to bring closer to the screen. And remember that I told you that this is areas under the standard normal curve from 0 to Z, right? And then this is a distribution curve or the normal curve that I've drawn there, okay? And then these are the values of Z, right? In one decimal place. And then these are the values of Z, which is second decimal place. So for instance, this is one is read 1.0, but if you have a certain probability here, we read 1.03. Right? So we read just 1.0, yes, 3, if this is the probability. So how can we find our desired response, right? The way we find our desired response, we say that we have to find the probability of 0.47. So 0.4, where does 0.4 began? So 0.4 began somewhere else here. But again, the next decimal place, the second decimal place is what? Is 7. So you have to look for 0.47, something it has begun at this point. Let's say come here. Then the next decimal place is 7.5. So this is not 7.5. And this is 0.4750. So you see? So this is the probability that we have there on the blackboard. So that its corresponding value of Z will be, you read this value in horizontal, 1.9. And then we add, we sort 0.06, and we get at 1.96. So then we say that Z has significance level 0.025. This is equal to what? Is equal to 1.9 plus 0.06, and the response is 1.96. That the value of Z at half of the significance level. So afterward, so you have that value. What next? So now we can do our computation and find difference between what the means of what of population. Difference between populations mean. So how do you find it? So you have the formula. So you say the difference between population mean. Population means this will be given as what? It's 1 minus mean 1 minus mean 2. 1 minus mean 2. 4.1 minus 3.5. So this is according to this formula, right? According to this formula. So 4.1 minus what? 3.5. Then you have plus or minus. The standardized value, it is what? 1.96. And then so we need what? We need to find the square root of this variable. But we can do it separately, right? So we can do it separate, and then so we break the response there in case that you want to avoid confusion. So this is mean and this is y. So if that the case, we say that we have determined first the sampling distributions of means, or the difference of sampling distributions of means. So this one minus this will make it square root of what? Variance of x. So the variance of x equals, it is one standard deviation towards 1.2 square. But remember that you can get the standard deviation from variance, and you can get variance from the standard deviation. So our sample size. So the sample size here is 32 plus plus what? Plus 0.9. So 0.9 square of 40 over 32, right? Over 32. Hence, so if you use your scientific calculator properly and accurately, if you don't have one, you can order it online. Go to the description below, you see how you can order. So when you do these computations, we get 0.26, then what? 52. Right? That's the response. So if that's the response, then we say that difference between population, between population means this will be equal to what? 1, 11, or 1 minus 5 is not possible. 11 minus 5 is equal to what? Is equal to 6. And then 3 minus 3 is this 0.6 plus what? Product of 1.96. You multiply by using a scientific calculator with 0.2652. Right? So if you use your scientific well, or if you use your scientific on this multiplication, you end on having 0.6 as a difference in means. Then you have plus or minus, excuse me, here we have plus or minus of what? Of 0.52. Make sure that you do it. So then now we can conclude that the estimate of the difference between the population means by that one, so we say that the difference, the estimate, say estimate, the estimate of the difference, estimate of the difference, estimate of the difference between population mean. Statistics is beautiful subject. Between population mean. Do you like mathematics? Please tell us if you do. Remember that population means. This material might be used in any continent, in any country. By what? By means of what? By means of a 95% confidence interval. Confidence interval is, so this one is 0.6 plus or minus 0.52. So that's the final response, right? So check if you have got, in case for those that who did this homework, check if your answer is right. In case that you didn't manage to get the right answer, don't be discouraged. Learning from mistakes is very